is Newton's second law of motion? You read and see what is Newton's second law of motion.
The acceleration of an object is directly proportional to the net force acting on it. The acceleration of an object is inversely proportional to its mass. The acceleration A of an object is directly proportional to the net force acting on it and inversely proportional to its mass.
Okay, so actually the second law of motion is like this. The net force acting on an object will cause the object to accelerate. The net force is equals to the mass multiplied with the acceleration. The mass of the object is constant. We are not interested in the mass. We are more interested in the acceleration. So when you make the acceleration the subject of the formula, you make acceleration the subject of the formula. So the acceleration is the net force divided by the mass. So we say that the acceleration is directly proportional to the net force. Why? Because the A and the F, they are at the top of the equation. We also say that the acceleration is inversely proportional to the mass. Okay, so from this equation, acceleration is the net force divided by the mass. It means that the acceleration is directly proportional to the net force. The bigger the net force, the bigger will be the acceleration. Okay, but because this m is at the bottom, you cannot say it's directly proportional. Since the m is at the bottom, we say that it is inversely proportional. So if it is inversely proportional, it means what? It means that if the mass is big, the acceleration will be small. If the mass is small, the acceleration will be big. This is the reverse of its relationship with the net force, right? For net force, bigger the net force, the bigger the acceleration. The smaller the net force, the smaller the acceleration. So what they are saying here is about this equation, F equals to ma. The net force is equals to the mass times the acceleration of the object. Now, when you look at an object, at first it is not moving, finally it is moving. So that means there is an acceleration. Because there is an acceleration, we know that there is a net force acting on the object. If there is a net force acting on an object, how much is that net force related to the acceleration of the moving object? So that net force that is pushing the object is proportional to the acceleration. So we see that if the faster the acceleration, the bigger the acceleration, then we know the bigger is the net force. And if we see that the acceleration is not so fast, not so big, we know that the net force is not so big. Okay. Of course, another factor will be the mass of the object itself. If the mass is very big, then it will not accelerate so fast. If the mass is small, then it will accelerate faster. So this is the mathematical relationship. From the formula, we can actually guess the relationship between these three variables here. Okay, one more time. Number one, acceleration of an object is directly proportional to the net force. Okay, directly proportionally for, now this is the reason why. Because the acceleration is at the top, the force is also at the top, so when one increases, the other will increase. When one decreases, the other will decrease. That is the relationship between acceleration and the net force. That is the relationship between the acceleration and the net force. Okay. Now the second statement here. Acceleration of an object is inversely proportional to the mass. Okay. Acceleration of an object is inversely proportional to the mass. So it means that if the mass is small, acceleration is big. Mass is big, then the acceleration is small. So it comes from this formula. Right. Now, what is the unit for force? We always stick to this formula. When you do any calculation, you just stick to this form, F equals to ma. Right. Now, the unit for force is Newton. 1 Newton is 1 kilogram meter per second. Okay, so this is the unit. Now we look at the quiz. We look at the quiz here. Or before we go on to the quiz, any question you want to ask me regarding F equals to ma? All you need to remember is F equals to ma, that's all. They just play around with the formula, right? Okay, so now you look at the quiz 4.1. Which of the following statements are true? So you read the first one, then I explain to you, then after that you read the second one. You read the first one enough. A.
An object can move even when no force acts on it.
An object can move when no force acts on it. This is true. This is true. Now, why is it true? If the object is already in the state of motion, if the object is already in the state of motion, it will continue to move. You don't need any force to make it move. It will continue to move. And this is clearly stated in the Newton's first law of motion. This is clearly stated in the Newton's first law of motion. The Newton's first law of motion say if the object is moving with constant velocity, it will continue to move with constant velocity. You don't have to push it. You don't need a force to push it to move. Okay, so this statement is true. Okay, next one. You read the B.
If an object isn't moving, no external force acts on it.
This one is not true. This box is not moving. It doesn't mean that there's no force acting on it. There are two forces. One is the weight of the object. The other is the reaction of my hand. My hand is supporting it up. The weight is pushing it down. So there are two forces acting on the box, and the box is not moving. But there are forces acting on it. But these two forces, they balance one another, that's all. So to say that there is no force acting on it is not true. It's false. You read C. C.
If a single force acts on an object, the object accelerates.
This is true. If there's only one force and there's no second force to balance it, there's nothing stopping the object from accelerating. Let's say there's an object, I give it a force, it will move, right? It will move. So why it shouldn't move? It will definitely move if there's a force acting on it. But single force, no. Let's say if two forces, maybe it will not move because the two forces, you push it this way and you push it backward, so it will not move, right? But single force, there's nothing nothing counteracting the first force. When you give it a push, the object will move. So this is true. You read D and say D.
If an object accelerates, at least one force is acting on it.
This is true. If the object is accelerating, we can see this is one of the effect of force. An object accelerates, right? So if you see an object is accelerating, there must be a force behind it. Something must be pushing it, right? So at least one, okay, it can be more than one, but no need to confuse yourself with many forces. Just think of one or two forces enough for you, right? So if there's acceleration, there is force. Okay, D is true. You read E.
If an object isn't accelerating, no external force is acting on it.
This one is not true. If it is not accelerating, there may be forces acting on it. The forces just balance one another. So when these forces balance one another, there is no net force. That's why it isn't accelerating, right? So it doesn't mean that if it's not moving or it's not accelerating, there is no force. There are forces acting, at least two of them, but then they are counteracting one another. That's why the object is not accelerating, or that's why the object is not moving. So E is not true. No force acting on it is not true. F, you read F and see.
If the net force acting on the object is in positive x direction, the object moves only in the positive x direction.
If an object acting on an object is in the positive x direction, then the object must also move in the positive x direction. Now this is not true. Why? Let me explain. Let's say if the object is moving straight, right? And a force, of course, if it comes from behind, then it will continue to move straight. But if the force is coming from the side, bang against it, bang against the object, right? So when you act on it, then the object will turn, but it will not turn 90 degrees, it will turn slightly like that. So it will not move in the direction of the force. What I'm trying to say is that when the force is acting on it, it may cause the object to change direction, not necessarily follow the original path of the object or follow the direction of the force. Unless they are parallel, the force and the motion of the object, they are parallel, then you exert the force on it and they will continue to move in the same direction, x direction, then they will move in the x direction. But that is not always the case. The force not necessarily parallel to the motion of the object. The force may be perpendicular or maybe acting at an angle to the motion of the object. So as a result, the object will turn, but not 90 degrees in the direction of the force. No. Okay, it will turn a little bit. So to say that if it is in positive x, the motion must positive x is wrong. It will cause it to turn only. It will not cause it to move in the same direction. So that is false. Any question on the sixth statement there?
No question, sir.
Of course, all this, I use the mouth to tell you. So when you listen, then you may forget. If you forget, then you just play